from University of Delaware. She's an assistant professor there. She's the associate director of the Center for Experimental and Applied Economics at the University of Delaware, and she got her PhD from Michigan State in 2015. Am I getting all my facts straight? Great. All right, take it away, Leah.
This morning, I really appreciate the invitation, and I also love the diverse group that I see here. That's pretty unique for me, so that's really special. It's been great to meet many of you over the past day and a half, and for those I haven't met, I'd love to chat with you a few minutes after the seminar today. So my understanding is we have an hour and a half, and I'm going to tell you a little bit about how I want to use that time. So I'm going to say a few things at the beginning just to let you know a little bit more about me and kind of the perspective I take when I think about things. Then I'm going to spend about 40 minutes on a paper. So this is an economics paper that I'll share with you all. And I want to save some time at the end to think about or to talk about some of the current work that I'm doing in addition to working on topics like the paper I'm going to present. And then talk about my vision for how I see my work kind of changing and evolving moving forward. I'm happy to take questions throughout the presentation. I will keep an eye on time to kind of make sure I can get through all of those things. So if I don't feel like I'm kind of rushing along, if you ask me a really great question, hopefully we can come back to it at the end. But I'll try to do a good job managing that time. So as Charles said, I'm Leah Palm-Forster. I've been at the University of Delaware for almost 5 years now. And so I was at Michigan State before that, and also Virginia Tech before that. So I'm originally from Virginia. I grew up on a corn and soybean farm, so I've been interested in agriculture a long time, and specifically thinking about the intersection of agriculture and the environment, and thinking about how we can manage working agricultural landscapes to get more environmental benefits. So I think a lot about water quality, but I'm also interested in talking about other benefits that we can get in agricultural landscapes, including things like wildlife habitat, pollination services, and other types of ecosystem services. So as an agricultural and environmental economist, I use a variety of different tools. In the past 5 years, I've used primarily experiments or surveys to get primary data and understand behavior of producers and landowners and understand why they manage their farms the way they do, and how we can design programs and policies that are cost effective and provide the right incentives to help those farmers and landowners use practices that support environmental services. Okay? So today I'm going to be talking about a laboratory experiment. So the way I view laboratory experiments, these are often with student subjects, and these are a great way to understand basic elements of behavior and how it compares to our theoretical predictions that we get from our economic models. Then I like to go out in the field, work with the stakeholders themselves, which becomes a very context-rich environment that we're in, and we can really understand all of the kind of details about the small things that matter in a program or a policy and how they experience those and interact with those and how that influences participation. Okay? I also use surveys, often just trying to understand basic things from a wider group of producers or landowners or stakeholders, and trying to understand what management practices they're using currently, why they're doing that, what they would be willing to change under different policy or program scenarios. And then something I'd like to do more of is coupled modeling. So I did a bit of this. My first paper that I published in AJAE, it was a simulation model. And what we did is we took what we learned from experiments and surveys about behavior, and then we linked that to the landscape. And I worked with hydrologists to do that and understanding, okay, based on the behavior that we understand, what does it mean for landscape level changes in terms of phosphorus loss into the Maumee watershed, which feeds into the western basin of Lake Erie. I'd love to do more of that kind of work, so I wanted to mention that. Okay, so it's my basic overview before I jump into the paper. Oh, I do have a clicker, wonderful. All right, so the project I'm going to talk to you about today is using a laboratory experiment to explore the opportunities to link agricultural subsidies that farmers already get to water quality outcomes. So I'll explain more about that in a moment. I want to acknowledge my co-authors, though. So this work is joint with Jordan Suter, who's at Colorado State University, and Kent Messer, who is at the University of Delaware. All right. The motivating question for this was that we use different tools to support farmers right now. So there's different programs through which farmers can get subsidies to help support their production, right? And are there ways to connect these subsidies that are already provided to the environmental outcomes that we want, right? So in this case, improved water quality. I'm going to motivate the project a little bit more, and then I'm going to present a theoretical framework. So this is kind of our basic economic framework that we're working from. And I'm going to talk about a couple of different proposed policies and how that changes that basic economic framework. And then I'm going to present theoretical predictions of how we think people would respond under those policy mechanisms, right? And then present an experiment in which we say, okay, well, how did people really respond? We have our theoretical predictions, but now what did we really see in terms of behavioral change? And then go through results and discussion, and I'll save that time at the end to talk more about my research program. Okay, so in the United States, as I think many of the in this room probably recognize, we have highly productive agricultural lands, which is wonderful because we are really efficient at producing food, fuel, and fiber, which we depend on every day in more ways than we recognize, right? But a consequence of this highly productive land is that we also have some negative externalities with this, in that, for example, we can have nutrients that if they aren't taken up by the plant, they are lost to the environment. So this creates a non-point source pollution problem, and it's difficult to tackle because it's coming from a number of different producers across a very large portion of the landscape. And so thinking about how to design effective policies to think about handling that is very difficult, right? And this is just, I know it seems like it might be a little hard to see the slides, but water quality issues here, you might think about the hypoxic zone in the Gulf of Mexico. Where I'm from, we think a lot about the Chesapeake Bay. Where I did my PhD, we think a lot about Lake Erie, right? And these are global issues, really. So in the United States, we really rely on voluntary working lands programs, which farmers can opt into, and they provide support in a number of ways, cost share payments or annual stewardship payments, to help them adopt practices that improve water quality and other key environmental outcomes. Importantly, a lot of these programs are practice-based, meaning that we're paying for the adoption of the practice, not necessarily a change in water quality. So kind of keep that in the back of your mind, all right? And a lot of these programs are run out of USDA through NRCS, Natural Resources Conservation Service. All right, over time, so we spend about $6 billion a year on these voluntary programs, and interestingly, an increasing proportion represented by the blue part of this graph, increasing proportion of that funding have been dedicated to working agricultural lands, right? So these are productive landscapes, not taking land out of production. And this is in recognition that we need that joint production. We need all of those marketed goods that we get from agriculture. It's incredibly important to us. We also want to have these environmental services that are also essential, right? So this joint production has really been emphasized. Okay. This is just a graph from 2009 to 2016. Couldn't find an updated version in the last couple years. But it's also, we also have a lot of other ways that we support farmers outside of agri-environmental programs, right? So subsidized crop insurance is one of those, right? And we actually have 90% of the cropland, which is insured, and that's federally subsidized insurance. So there's other ways that we support farmers. So my idea here is thinking about, well, how could we link the joint goals that we have, supporting farmers and also protecting the environment? Conservation compliance does that, really. So it tries to link those two. The idea here being that conservation compliance currently really focuses on protecting highly erodible lands and wetlands. And the idea here is that in order to be eligible for some of those federal programs, subsidy programs, farmers have to comply with these conservation rules. Okay? This emphasis, the linkage between the programs, was actually strengthened under the 2014 Farm Bill and has continued to be strong under the new Farm Bill. All right, and there's also some state level programs in Florida and Wisconsin that also tightly link conservation compliance to different benefits like tax credits that are provided to their producers. All right, so that's kind of a landscape of some of the tools that we're using now. But now I want to take a moment to kind of look at what other things have been explored in the economic literature. Because remember, a lot of what I talked about that we're currently doing is linked to practices themselves, right? In the economic literature, there's been a real focus on, well, how do we move towards performance-based programs? So actually paying for the improvements that we want, not just an input that we hope links to an improvement. Okay? So there's a rich literature on what we call ambient pollution policies, right? These include taxes and subsidies that are linked to ambient pollution, which would be measured down here, downstream somewhere at some sort of outlet, which would indicate the outcomes of practices across a larger area of the landscape. So you couldn't link what you measure down here to a specific operation or producer, but it's more reflective of what's happening in a full watershed. Okay? Now, some of you are probably already thinking, well, if my taxes or subsidies are linked to that, that doesn't really seem very fair, because what if I'm doing a really great job and others in the watershed are not? That has been one of the biggest critiques of these types of programs, is that there's a big equity concern. But we are incentivizing the outcome that we really want, right? So that's the strength of it. Okay? So these are pretty politically unpopular. We don't see a lot of examples of things that have been done. Some people talk about the TMDL in Chesapeake Bay sort of looking like this, but it really doesn't function like it was laid out in the literature. So my idea was, is there a way to link these things together? So, and I will admit, in my approach, I'm probably making conservation compliance, which is widely supported by both the agricultural community and the environmental community, probably making that a little less popular. But I'm making the idea of these ambient solutions a lot more palatable, right? So maybe we can find some middle ground that at least allows us to start a conversation here and explore those opportunities. So that was my broad goal. And the specific objectives were to use that economic experiment to see how a subsidy reduction, so this is the idea that we're getting producers are getting subsidies through these farm programs, but we could reduce the amount that they're able to get if we're not meeting water quality targets. How does that perform relative to these ambient taxes in the literature? But also, what could we do to make this feel more equitable, right? Well, maybe a producer could demonstrate that they are very committed to stewardship, right? And by doing so, they take an action that demonstrates that, and they would be protected from any types of subsidy reductions that would be faced based on these ambient pollution outcomes. So it's trying my attempt to make this a little bit more palatable. So these are the things we're going to explore. And we call these individual assurances. They take an action and you have this assurance, you will not be subject to a penalty because you've demonstrated that commitment. All right, so for those of you who are not economically inclined, don't worry if this part gets a little weird. I'm going to try to step through it and make it very clear, but you don't really need to pay too much attention to the mathematics here. Think about a watershed, so we're going to simplify. Think about a watershed with agricultural producers, and imagine they're all the same. I know this is a simplification, we can talk about it later, but it gets real hairy when you start letting everyone be different. To be simple, we're going to let them be the same, and we're going to assume that firms are profit maximizing. And profit is a function of input, which is X, and also the adoption of this costly conservation practice, which is A. Okay? And profit's a function of the fact that you have this government benefit, this fixed payment or subsidy, right? The income, which is based on input use. And then we're going to just focus on one cost, right? We're going to assume all other farming costs are captured in that income function. But the other cost is going to be associated with adopting this costly conservation technology. And we're just going to let that be binary, so it's going to be 0 or 1. You could think of it as one practice, a suite of practices. We're going to stay general here. All right. Now what happens on the pollution side? Well, so production also generates firm emissions. So emissions from individual firm are lowercase e. They're a function of input and also the conservation technology. Total ambient pollution is just going to be generated by adding up all of the individual firm pollutants and those emissions, right? We could have much more complex functional forms that take into account spatial heterogeneity, but we're assuming everyone's the same right now, so we're just going to add those up. Okay? And then total economic damages is going to be all of that ambient pollution, and then we're going to multiply that by a social cost of emissions, and that's D. So that's what's happening there on the water quality pollution side. And then we're going to think about, we know the farmers are profit maximizing. The social planner's objective here is going to be to maximize social net benefit. So from that perspective, we want to maximize profits, but also take into account that we don't want economic damages, right? So that social net benefit is all those profits added together minus those damages from water pollution. So that's the basic framework. Now what I want to do is I want to look at how that framework changes in 4 different treatments. So we have our no policy control. Then we're going to look at how that differs when we talk about an ambient tax. These are in black because they're not novel parts of this paper, really. One's a baseline. The other's been done and looked at in the literature extensively, but also kind of serves as another baseline. The new policies that we're going to look at are the subsidy reduction alone, and then what I call the subsidy reduction with assurance, which means, again, that's an individual can take a costly action and be protected. So the no policy control, everything looks just like what I said. Firms profit maximize, social planner wants to maximize social net benefit, no differences. Things get a little different when we look at the ambient pollution policy. So now in that profit equation there, we have to subtract this ambient tax, right? What this tax is it is a tax that everyone has to pay on every unit of pollution that exceeds a set threshold. So if pollution is above that threshold, everyone pays a set tax for every unit above that threshold. You're only paying if it exceeds threshold Z bar. Okay? The social planner's objective looks the same, but importantly, when we set the marginal tax rate, TAL, equal to those the social cost of emissions, D, then the 2 problems align, right? So the producers fully internalize the cost of those emissions, and they will then, in theory, produce at the social optimal level in which they're putting just enough inputs in to kind of balance the benefits from production, but also not expose themselves to that tax. Okay, so that's the ambient tax. Now, here's the difference with a subsidy reduction. Just to emphasize, this looks really quite the same. The only thing that's changing really a little is the function for how that subsidy reduction is generated. Because if you remember, that subsidy is G. So the reduction is capped at G, right? So even if pollution increased a lot, you can't lose any more than G. Right? With the ambient tax world, ambient taxes could just increase indefinitely, but now they're capped. So at the margin, for small changes and increases in pollution around the threshold, the subsidy reduction and the tax look the same, right? So now we have R and the difference between the observed pollution and the threshold. Before, we just had TAL and that same difference. So it looks the same there at the margin. But beyond a certain point, after you fully exhaust the subsidy, it can't get any higher. The reduction is just G. So that's the difference. Again, if the two, if we set R at D, the social cost of emissions, then we're going to have the problems aligning again between the producer and the social planner. And we're going to talk about this. The introduction of G here is actually going to create a second Nash equilibrium, which we'll talk about in a moment when we look at the predictions. Okay? And then the subsidy reduction with assurance, it actually looks pretty similar, but now a producer can adopt this technology, this costly technology. They're not exposed to the subsidy reduction. So their decision basically becomes, I'm going to choose A if I think that I'm going to be better off by absorbing the cost of the technology, but not being exposed to the potential subsidy reduction. Otherwise, I'm going to not choose to adopt that technology. Okay, social planner's problem. I just put it up here to emphasize it's the same. It always stays the same. It's never changing. Okay, so in a moment, I'm going to talk about the parameters that we used to parameterize this model, and that generates theoretical predictions. Before that, I want to talk about how we studied this. Again, I said I used different types of experiments. For those of you who are not economists, it might seem quite strange to be in a lab and using students as subjects. But actually, it provides us a good foundation, a first step, to understand how behavior compares to theory, right, in a very kind of simplified context without all of the richness of a true agricultural setting. So I want to acknowledge that, yes.
Before you jump into the experiment, so from the firm's perspective, they don't know whether they will have the subsidy reduction put in place. It's probabilistic. So there's no definitive mapping of their actions in the subsidy reduction, or just a definitive mapping?
So the definitive mapping, so they know what generates the subsidy reduction, and that is pollution that exceeds that set threshold Z bar. But there's other people in that watershed, right? N-1. Yes, it is. It aligns exactly like that at the margin. The difference is just that it's capped at a certain point. The assurance, there is a very clear mapping. If they adopt the practice, it is a way to just step into a world in which you've demonstrated your commitment, you will not be penalized. Does that make sense? Yeah, great question. Yes? Absolutely. So again, yeah, under that assurance model, whatever the other people in your watershed are doing is independent. I like the way you put it, a clear mapping, and that way you have a clear mapping to your outcome by adopting the conservation technology. Regardless of whatever happens, you've shown you are a good steward, you're not penalized. Yeah, any other questions? Thanks for that. Okay, great. All right, so yes, so in the lab we answer these basic questions, and then it's a great starting point before we go out in the field and get really into all the details, right, about how this would be implemented. So we did this in our lab at the University of Delaware with 156 students. They did not act as farmers. They were just managing generic firms, so we did not enrich it with a context of agriculture or anything. We were just seeing basically how do they respond to these mechanisms. They were groups of 6. They represented a watershed. It was a within-subject design, meaning that they went through each of those 4 treatments that I described, 5 rounds per treatment, so 20 total rounds. The group reassignment happened between treatments. So groups got mixed up. They participated in 5 rounds. Groups got mixed up. Okay? They didn't know who was in their group. They were making decisions on a computer, a bunch of other people in the room. And so there was not an opportunity to communicate or create bonds that, of course, would exist in real contexts, but we were trying to have more control so that we could just really identify what would change when we presented these new mechanisms. So they came into the lab, they did instructions, they did a practice. It's really important. It's not a simple thing, so we need to really make sure people understand. They did the experiment and a short survey. And then we did a Holt-Lowry risk elicitation task to try to understand something about their risk preferences. For the economists in the room, we can have an argument later about whether we can really measure risk preferences well with the Holt-Lowry. And I'll come back to that thought in a moment when we talk about results, because not surprisingly, we did not find a lot of effects of risk preferences, likely because of how we were measuring them. In general, students earn just about under $32 for an hour and a half. All right, so this was the parameterization. We really don't need to get too in the weeds about it. I want to highlight a few important things. So it was a quadratic production function. So the optimal decision was, we'll see it in a graph in a minute, for farmers to produce at 6 units of input if there was no policy and they were just maximizing profit. We had a subsidy. It was set at 400. The emissions function was such that if you adopted that conservation technology, it cut emissions in half. So it was whatever emissions level was generated based on input level, and then it was halved if you adopted the conservation technology, which cost 150 experimental dollars. Pollution function, like I said, is just linear. And the damage function, the social cost was 52. This is not parameterized to represent any specific type of agricultural setting. This was really context-free, not parameterized in that way, and we're just looking at these behavioral changes. All right, so just for those of you who are more graphically inclined, this is what the profit functions in green looked like with technology 1, which was a traditional technology. Technology 2 in the open triangle versions of the curves. So you just saw this kind of downward parallel shift because it was $150. And then the emissions units of pollution. So these just increase linearly with input, and they were halved if they adopted the technology. Yes?
Sorry to be the troublemaker.
It's okay.
Explain a little bit more details about the procedure of the experiment.
Sure.
Because for this kind of experiment, 1.5 hours seems too long.
Yeah. We were pushing the boundary on an hour and a half. So you want to know, the detail you want to know is just...
What decision did you really make in this experiment?
Here you go. Good question. You're moving me to my next slide. So what they were doing was they were making 2 decisions in each round, a management decision and a technology decision. Again, they were not told to act like farmers, but the unique thing about experiments is whatever the participants were doing in this section, or in this session, excuse me, they were earning real dollars at the end. So all of the decisions they made were generating real payoffs. So they wanted their firm to do well in the activity, right, in the experiment, so that they could generate those. So getting back to this, they made a management decision and a technology decision. Technology decision is represented here, so technology 1, technology 2, management decisions along in the rows. When they would click on them, it would highlight the columns so they knew what was applicable to them, what they were, what the outcome would be. Then they had also a pollution calculator. First of all, it told them what their firm profit would be if they, set everyone else to, not doing anything. But then they could test. They could say, okay, there's 5 other people in my group. I think one of them's going to adopt technology 1, another's going to adopt technology 2. They're going to generate, these amounts of pollution. It was all very transparent. They also knew everyone was like them. So they knew what their own incentives were, right? And this is really important. That's an important aspect to know because that's how we can generate our Nash equilibrium predictions. Yes?
Perfect monitoring of the pollution.
Yes. Yeah, we're assuming perfect monitoring of pollution, that we see exactly what comes out and there's, no noise there. So, yes.
I think you just said this, but I want to make sure. So each of them know that basically their marginal impact on damages is the same as everyone else's?
Yes.
The transfer coefficients are all the same?
Yes. And this,
If you relax that, then you have even more problems with the MASH.
so I direct you to the paper that came out this month in Resource and Energy Economics, in which we relaxed this assumption, and therefore have a lot of appendices to calculate those. And it gets pretty gnarly. And actually, Shangwu, who I mentioned, we were talking about last night, he's the PhD, the lucky PhD student that got to crank through all that, and then I got to check. So, yeah, it gets messy. So something to know about experiments is if we want to just test, we can't change a lot and then really say that we've captured the effect of one change, right? So we're changing one thing at a time in principle. Often it gets a little messier than that. But that's part of why this seems like, oh, this is very oversimplified when we want to relate this to agriculture. But again, it's the first step in understanding behavior. So I know that there's a lot of folks in here that are not economists. I'm happy, I would love to hear your thoughts afterward about it. But that's kind of the motivation. I want to explain why it looks like that. Okay. All right, so our theoretical predictions in no policy firms profit maximize. They're not internalizing any of those social damages. They produce 6 units of pollution, 36 in total because there are 6 of them in the group. Under the tax, they internalize that cost. Therefore, the social optimum is for everyone to produce 3 units and for the total ambient pollution to be 18 units. Now, importantly, it is parameterized, so it's very you can actually reduce pollution more cheaply by reducing inputs, not the conservation technology, which is costly. Motivation for that being that, yes, it's costly, but it's very visible, and that's how we could link it to assurance. But there are many ways that a farmer could reduce pollution, right? So in this case, in this experiment, it's cheaper to do it through input changes. So the NASH here is actually that they don't adopt the conservation technology, that they just back off on input use. So subsidy reduction is one thing. It gets a little bit interesting because the subsidy reduction is capped, we have a second NASH equilibrium. And that is that farmers produce all the way at the privately optimal level of 6. Now, when we have the subsidy reduction with assurance, we actually have the same NASH equilibrium prediction as we do with the tax. Right now, though, as you've probably picked up on, we haven't talked about risk preferences at all. We're talking about risk-neutral, profit-maximizing firms. That's going to come in just a couple of slides, so if you can bear with me for a minute, I think we're going to answer that question. So yes, for a risk-neutral, profit-maximizing firm, that's the NASH, but we'll talk about that introduction of risk preferences in just a moment. All right, so moving through, we're going to test some null hypotheses. One is that we're not going to see differences between the pollution levels when we compare the tax with the subsidy reduction to the subsidy reduction with assurances, because the marginal incentives are really the same. So we think we're not going to have any differences there. The econometrics isn't really fancy. We're going to use random effects linear models to look at pollution. And we're going to use categorical variables for the treatments. We're going to control for order effects. I don't know if I mentioned it. We used a Latin square orthogonal design just to make sure that the order was changing. And we are also going to control for round effects. So hypothesis 2. So hypothesis 2 being that the policy treatments are going to have no effect on the conservation technology. So the theoretical prediction says that should be true. But we were actually thinking it's probably not going to be true. We'll test that null hypothesis. But as I jump to the next slide, you can see that although it's not a Nash equilibrium for them to adopt the conservation technology, when we introduce risk preferences, we actually see that for risk-averse individuals, right, if all of a sudden we put them into kind of a utility maximizing space based on von Neumann-Morgenstern utility function and using these kind of relative risk coefficients, if the coefficient is above 0.481, we actually would expect them to move and adopt the technology. And we grab that coefficient and determine whether they're risk averse through the Holt-Lowry risk elicitation task, which for those of you who are not familiar, people are going through and making decisions in 10 different rows between a sure bet amount of money and a risky gamble, right? And when they start picking that risky gamble, that allows us to measure how their risk preferences, if they're risk-loving, risk-averse. So the way that we then capture this and incorporate in our model, now we use a random effects probit, and then we add a binary term in for whether the individual is risk-averse. And I'll tell you exactly how that's measured in a moment. I'll show you the histogram of the outcomes from the Holt-Lowry, and then interact that with the treatments, right? Because we're expecting that this is going to happen in treatment 4, because that's where a risk-averse individual would say, I know exactly what happens if I do this and I adopt this technology, right? It might be costly, but I've demonstrated my commitment and I am good to go. No penalties based on what others do. So that's where we think we're going to pick this up. All right, and then the hypothesis 4 is that, if this is happening and we have risk-averse people using this, taking this action, adopting the technology, then the social net benefit will actually be lower in T4. This is not necessarily a bad thing. I know economists are like, what? We think, we'll talk about it in the discussion, it could actually just represent kind of this cost of creating this kind of protection for individuals who take an action. So it's almost like the policy cost of like introducing this equity into it. So we can debate on whether it's better or worse, but we think that it could be an acceptable cost to have, right, to make this palatable. All right, and in this case, really, we're going to see the regressions when I show the tables. It really looks the same, except now we're going to use social net benefit. We're going to model social net benefit, which we saw. That was the social planner's problem. All right, so now I'm going to show some outcomes. The group pollution here, we actually find that among the 3 treatments compared to the no policy control, we see that reduction in pollution, but there are no differences between the 3 treatments. The easiest way to look at this is graphically. I'm very graphically inclined, so it's just easier to see it here. Big drop down to the socially optimal level of 18 when we have our different policy treatments, but no statistically significant differences between the pollution levels for those treatments. Okay, so, okay, what does that mean? It means, oh, this could work, right? We could, if we were really trying to get our pollution down, we're seeing that happen. Great. This is just that random effects model. We're not learning anything new about the pollution levels, but I wanted to show it to you to confirm and assure you that we didn't actually find any big round effects or order effects when we controlled for those things in the regression. And the stars up there they all look significant just because it's compared to the baseline, right? And pollution went down under all the treatments. But if you did pairwise comparisons, none of those are statistically different. Sometimes it looks like, oh, there's all these differences. There aren't between the 3. Okay? And now I'm just assuring you that we didn't have those changes. The way I did the orders was I put in categorical variables. Did they see treatment 2 first? Did they see treatment 3 first? Did they see treatment 4 first? Okay, so result 2, we found that although that Nash equilibrium would suggest that people wouldn't adopt this costly technology, we saw that under T4, which is this orange line, we saw a much higher rate of adopting of the technology and assuming that cost. And so right now this graph I'm showing you across all 5 rounds. Sometimes you see some different behavior convergence to one strategy or the other across rounds, but really we saw the stabilization of the adoption of that technology and not much for the other treatments. So we saw that about 50% of people on average were adopting the technology in treatment 4. Yes?
Just let me clarify. So you see more people using the better technology, but the overall pollution level is the same. So in other words, the technology do not help the pollution.
So the technology helps us achieve pollution right around that threshold, but it's through a different mechanism. So they could reduce pollution by changing input level. They could reduce pollution, thank you, by adopting the technology. There's 2 mechanisms with which to do it. In the other treatments, they just chose to do it through the input level. Right? Yeah, that's a great question. Okay. And so what are we learning here? Well, we actually don't find any impact of risk preferences on this adoption. So we see that we have all these people in T4 adopting, and we think that should be related to risk preferences. But when I put in a coefficient for that risk aversion, right, relative risk aversion, I don't see any impact. And even when I interact that, you know, we might think we see some impact by looking at the coefficient on the interaction between risk averse and T4, but we don't see it. I've cropped this. We also, same result, we don't have order and round effects down here. So when I add in those variables for risk, we don't see anything. Again, there are arguments that in a lab setting using a Holt-Lorry, we're not talking about a lot of money on the table. We're talking about gambles that change, you know, maybe you're going to earn $30. For students, they really like that. It's still not big money, right? And it's in one setting. So maybe we're just not picking up, you know, the effect of a risk preference, and that could be very likely. One thing to know about, the way to think about the literature, we're all building on each other. So observations are just building, and we learn something from each study. But this study is not definitively saying risk preferences have no impact. Of course not, right? It's one observation in a larger literature. So we talk about this too. Maybe we're just not able to pick it up. We need more research thinking about this. I thought maybe someone would say, well, how many people were risk averse, right? Yes?
When did they take the survey? During the actual process of the rounds? Or like at what point?
At the very end.
So could you be thinking maybe they were already kind of overdone with picking through things and ended up with some?
That's a great question. So thinking about when you're going to do the Holt Lorry, it's a tricky thing, right? We didn't want to do it at the beginning because all of a sudden people then are endowed with different kinds of, different amounts of money, right? And all of a sudden someone just feels like they won $30 and they're really happy, and maybe they act differently in the experiment. That's why we chose to do it at the end. Like if we were going to be really careful, it'd be really good to also do it at the beginning and then control for that. But that was the decision that we made.
Did you see any difference between male and female in terms of if you think you see it if you pulled it apart that way?
Good question. We often do see gender differences in lab experiments. I'd have to go back and look at that. I haven't looked at that specifically here, but I could look at that. Yeah. All right. So to answer the question, well, what do these people look like? So again, in the Holt Lorry, they're making decisions in 10 rows. The first time they switch over to option B tells you something about their risk preferences. So this histogram shows you how many people switched over at each row. And so based on the Holt Lorry design, if they switched over 7 and up, they're considered risk averse. And they estimate a relative risk coefficient 0.41. So if these are risk averse, that's what I created that binary variable to capture. I've also done some kind of robustness checks. Okay, maybe I'll put more people in that group by saying, oh, everybody after 5. Maybe I'll put less people in that group. Oh, only really risk averse people, 9 and 10. Results don't change. Yes?
Sorry, I'm not familiar with this.
Holt Lorry?
Yeah. So what is the choice option?
So it would be something like you can earn, and I'd have to go, but I can share with you the exact one we used here. You can earn $25 with certainty, or a 50-50 gamble. 50% of the time you're going to earn 0, 50% of the time 36, right? Something like that. And then those probabilities change as you go down. It gets less risky, right? Until the very end, it's like sure thing $25, sure thing $36. Of course, I'll always pick the sure thing. Right? All right, so we saw this result. We were kind of like, we didn't pick anything with risk preferences. So we decided to do kind of an exploratory analysis to see, well, but maybe there's something like in the past if you got penalized, right? It's within subject design. They're participating in 20 rounds. Well, what if you've already experienced a lot of penalties and then you get into treatment 4? You're probably likely to act different. Or what if you see treatment 4 first, right? You haven't had any experience. Maybe there's an effect there. So we didn't design the experiment to do this. So I like to emphasize that for folks that are really interested in pre-analysis plans, right? This is more exploratory. But what we did is we looked only at the decisions made in treatment 4. So this is only those decisions. And then we said, okay, well, let's throw that risk coefficient in there. We've already looked. We're probably not going to see anything. But also look at how many cumulative previous penalties did they experience when they got to that point. And then in which order did they make decisions in this treatment. So order 4, treatment 4, means that for these observations, it was the very first 5 rounds these participants made decisions in the whole experiment. So what we found is that we have found a significant impact of experiencing penalties in the past and adopting the conservation practice when you got to T4. So some protection, maybe some interest in protecting themselves against downside risk because they'd experienced that, right? And then also, if they saw treatment 4 first, they were more likely to adopt that technology. And to us, that kind of signals that, well, if you don't have experience and you don't think, you haven't figured out that people are, maybe converging to a Nash equilibrium in which you won't be penalized, well, then you might just be looking for a really simple, salient strategy to make sure that you are going to protect yourself from any losses. And so that's what we think that these results are suggesting. If it was your first experience in the experiment, or if you'd been penalized a lot in the past, then you were more willing to take that sure bet, right, and to do that. All right. Thinking about socials, this is the last result, key result of the paper. Thinking about, how am I doing on time? Oh, I'm really good on time. Okay. Thinking about the social efficiency here. What we measured was social net benefit. So I showed you that equation, right? Social net benefit is that you wanted to maximize all the profits minus the economic damages. Okay? And then social efficiency, the equation for that is down here in blue. I don't know how easy that is to see. But on the numerator, we have what we observed for the social net benefit minus the status quo, so the no policy control. And the denominator is the socially optimal social net benefit minus the status quo. So what this tells us is how much kind of gain in that social net benefit are we getting from the treatment itself, right? Okay, so when we look at social net benefit, actually because of how it's parameterized, there's really not huge differences. We see about 7% reductions in social net benefit when we're looking at going to the subsidy reduction compared to, sorry, I'm getting my numbers mixed up here. When we're looking at the tax and then we're looking at the two subsidy reduction outcomes, we're looking at less than 10% reductions in social net benefit. That's the best way to say that, right? We can see the differences a little bit more when we use the social efficiency metric, which kind of helps us scale for the fact that there's not big differences in magnitude between these numbers. But what we see is we see a social efficiency of the no policy of 0.06. So some people actually, even under the no policy control, were reducing pollution, taking an action, probably because they were putting their preferences right into the experiment. But we did see that under the tax and the subsidy reduction, we had these efficiency levels around 75%, but we actually dropped down to 38% when we add that assurance. Again, it's because that action is more costly. In reality, if that action was cheaper, it'd be a win-win for everybody, right? So we could talk about specific cases, and maybe that's true. It becomes a win-win. But here, we found that to protect themselves, they assumed more cost in reducing the technology. Okay, so those were the kind of basic outcomes there. All right, so what were we seeing? We were seeing that when we look at a subsidy reduction, when we look at the policy with assurance, the outcomes are very similar to the ambient tax, which in the economics literature is kind of our first best kind of world for controlling non-point source pollution. So that's exciting, but we see that, we know that in order to make that palatable, we need to be thinking about something that allows this protection based on me taking a costly action. And so when that happens, we see these kind of reductions overall in social net, social net benefit. But it seems like a strategy that's really salient and simple and that people take, especially if they're concerned about the penalties they might be exposed to. So let's go back to our actual policy world that we actually all live in and function in and ask what we learned from this. Okay, well, we learn that based on our theoretical predictions, when we look at participant behavior, that we actually see a lot more adoption and desire to kind of take this action than would be predicted. And then we learn also how it functions in a similar way to the ambient tax. Can we design policies to link this kind of compliance rules to existing subsidies? Well, we've already done a little bit of that. Can we do it to actually link it to the outcomes, water quality outcomes that we care about? Well, it seems like that's not a crazy idea to people. It's just, what would it look like? And so I'm going to talk right now about, well, we learn something interesting from this experiment, but there are also caveats that more research would be needed to address. right? What are those caveats? I've already mentioned that. We said that cost was like the cost of fairness. Caveats would be, first of all, in this experiment, we're assuming that everybody is participating in the subsidy, right? Everyone gets the subsidy, and thereby everyone doesn't want to lose their subsidy. But in reality, that's not necessarily the case, particularly if people feel like you're making a program seem less attractive than it was in the past. Well, a producer could just decide, I'm not going to engage in this program. Maybe it's not that important to their operation. Well, that would create some challenges because all of a sudden we'd have less teeth in the policy that we're designing, right? There wouldn't be a lot of that incentive there. And then that would create an issue because in a watershed, you want everyone to be on board since they're all contributing to that outcome that you care about. So you don't just want a few people to be subject to this. If people left or decided not to participate, it would just make everything harder and harder, right? So we'd really have to think about what that looks like. Of course, also, if we're talking about something like subsidized crop insurance, there's a lot of other details in how that kind of program works and affects a producer's kind of bottom line and how they think about their operation, right? So there'd be a lot of things there to think about. Okay? There's also a lot of other interesting behavioral drivers that I think deserve some attention. And I think that a lot of this work now, we really need to be out in the field, talking with stakeholders, understanding all of these details, right, and getting that rich context now that we have kind of a basic understanding about how behavior is affected. So what that leads me to is a few projects that were in some ways inspired by this earlier work. One is I was really, is Karen, I think Karen's not here today. We were chatting about this program last night. I was really inspired when I was in Michigan by the Michigan Agricultural Environmental Assurance Program, the MEAP program. So this is a program in which producers do exactly what I was talking about. They take actions that give them a certification that allow them to put a sign on their farm. And the MEAP sign is this one, right? This farmer just has a few more. But that one, put a sign on their farm to say, I am taking actions to be a good steward, right? And they get recognized for that. So I was really inspired by that, and so I wanted to say, well, in the experiment I just told you about, nobody knew whether you as an individual participant were taking that costly action, right? But what if you could then signal, like, I'm doing this, I'm contributing, right? What would those impacts be? This was also inspired by a paper that we published earlier this year in which the RARE organization, I'm not sure if you're familiar, they do a lot of community conservation. They use community mascots to get people excited about doing things that are good for the environment. So we wanted to test, well, what if people can signal, and then what if they're also getting feedback from a community figure, right, or peers, and how does that change non-point source pollution? So we did a similar type of lab experiment for this one, and we actually used our mascot as a chicken. So his name is UD. Although he is a chicken, people love him very much. And so we had students again, so we used a mascot they would care about, our UD chicken. And then peers, so other students at the university. But now they could actually signal, like I'm doing something to help the environment. And we actually found that the stewardship signaling increased the likelihood of using the technology, and in the parameterization of this experiment, increased the likelihood of meeting the pollution abatement goal, the signaling. We didn't find effects of the mascot like RARE and others had found in the past. People didn't seem to really, maybe UD wasn't as impactful as we thought. We didn't find that impact. We also didn't find it when they got feedback from their peers about the actions they were taking. So I just think that's kind of a fun experiment, and it's something that was motivated by that. The other work that I'm doing is, many of you might be very excited to know, with actual producers, not in the lab. So I think people get excited about this project. I'm really interested in how the enrollment of leased land. So how do land leases and the dynamics between the landowner and the farmer impact participation in conservation type programs, agri-environmental programs. And particularly because these relationships can look very different, right? The actual landowners might be 3 siblings that live in a city, and all these dynamics really impact. So what we did, we got a USDA grant, and I worked with an extension economist in Kansas and an economist in Nebraska. And so we looked at this in the context of the Conservation Stewardship Program in Kansas. And so the thing that's interesting about the Conservation Stewardship Program is that it's a whole farm approach. So if you enroll, you're supposed to enroll all your acreage. So if you're a farmer and you rent from 6, 12 different people, we had one farmer in Kansas, it was over 50 different landowners that he worked with. It was amazing. You're supposed to enroll your whole farm, and so you need a statement of control to be in the program to say that you can control that land for the duration of the contract. This, as you can imagine, really increases transaction cost of trying to think about enrolling in that program. So our hypothesis was actually that the more landowners you work with, perhaps the less likely you are to enroll. And we did a choice experiment to see, well, what if we relax some constraints, right? We didn't make you enroll 100% of the acreage. Maybe there's some small policy changes that would make that program more attractive. So we looked at that. I really love this project, and we're still in the middle of it, but I really love this project because it was kind of 2-tiered. The first 2 years, we were really focused on a survey of both tenants and landowners. And then in the latter part of the project, we did an artifactual field experiment, which is when you actually go and you kind of set up a lab-like setting, but you're with the actual stakeholders. So we actually invited, through Kansas State Extension, landowners and farmers into the room to engage in the activity and to have a discussion about their experiences. I want to mention a couple things about the survey first because we were really excited about it. So we did this kind of interesting method where we put these packets together with the survey. We sent them to the tenants because we had information about them from the Kansas Farm Management Association. And then inside, there was a packet that they were supposed to mail to the landowner of their largest lease. So we were trying to find creative ways to get matched pairs for the tenants and the landowners to learn about them. And we got about a 26% response rate from the producer surveys and a 20% from the landowners, which isn't horrible for a mail survey of the agricultural community. It's actually not bad. But that ended up actually only generating 317 matched pairs. So we're still in that data right now, analyzing that. But from looking at just the tenant or producer surveys, we found some interesting things already. Interestingly, they're more likely to enroll when they lease more acreage. So this might say something about the capacity of the farm to engage in these kinds of programs. We're not sure what this means, but if the landowners live off the farm, we find more likely to be in the Conservation Stewardship Program. And not surprisingly, if they themselves identify more environmentally or as a steward, they're more likely to enroll. We don't find that the number of landowners is reducing participation in the CSP. But interestingly, in that choice experiment, we talk about, what if you could split payments and both the landowner and the tenant could be paid, and we differ that split among some different values. And their tenants have very strong preferences for the landowners not to be paid. And we didn't understand this because actually, as we set it up, the tenant payment in many of these cases, it's independent from that landowner, so it's not like we're reducing the tenant payment to increase the landowner payment necessarily. But we're thinking in practice, though, when you look at it, it might just seem like, well, there's obviously more money on the table. Like, look at all this extra money you have over here, and you're giving it to the landowner, and what are they doing to actually comply with the program? So that's been an interesting thing for us to try to figure out. And we do find there's a little bit of an effect if we reduce the constraint that you have to enroll all of your land, and we allow tenants to just enroll a smaller proportion of the land. There's kind of a marginal increase in their willingness to enroll in the conservation stewardship program. But honestly, not as much as we had hypothesized. We really thought that was a greater constraint. So we're learning a lot there. We've just run the artifactual field experiments in the last year, and we are analyzing that data as we speak. Not surprisingly, if it takes more time to apply, people don't want to do it. So I don't think that probably shocks any of us, but it's a result that speaks to the transaction costs that are often involved with these types of programs. All right, so that is kind of the couple of the extra projects I wanted to highlight to give you a more full picture of the different types of work that I do. Doing a lot of other things. I get excited about a lot of projects. Most of them are focused in this kind of area. Doing some other work. I'm in Delmarva. We produce a lot of chickens in Delmarva. So it's, we're one of the leaders in broiler production. So we have a problem with chicken manure. So where does that litter go, right? We're a small area. We only have 3 counties. We got to move that somewhere. And so I'm working with some extension economists in plant and soil science at University of Maryland and University of Delaware thinking about that. I do have until 11:30, right? Okay, wonderful. I want to leave time for discussion, but. And then one project that's a little different is a project that I conducted with a student from Kenya. She came to UD as part of the Burrell Global Fellows Program. And so we went over to Kenya and did a field experiment with smallholder farmers in Kenya, looking at their willingness to invest in hybrid maize seed, which is more costly but also more productive than the local varieties. And we looked at that amidst concerns about fraud in the seed sector. And so we tested the value they placed on some novel features of those seed packets, particularly certification scratch cards, and we also did a training about best practices for buying hybrid seed. Yes, so that leads me to kind of my last talking point, which is about work that I'm really excited about moving forward. Let me mention one more thing before that. Another project that I'm involved with right now, actually sharing a co-author of the paper I just talked about, Jordan Suter at Colorado State, and a postdoc, Asanu Zaman at University of Delaware. We're also looking at the impact of uncertainty and ambiguity in common pool resource management settings. So that's been really some exciting work, through that project, I've been thinking more about the role of risk in decision making, and also the context in which we're doing this experiment in Delaware is about agricultural irrigation and the risk of saltwater intrusion into those aquifers. We're not really in a water-stressed environment in Delaware, but we do have that concern about a contamination, which really impacts quality of water that can be withdrawn for irrigation. So we've been looking at, well, if there's that ambiguity about whether or not that's going to happen, how might that impact withdrawal decisions, which can actually exacerbate that saltwater intrusion? That's been a really interesting project that we just started in the past year. And that's connected to this larger project, Project WICKED. We like to give acronyms to everything. Water in a Changing Coastal Climate of Delaware. I think our PI on that also really liked the Broadway show. So that's what inspired it. That's on his background now on his screensaver. Okay, so getting back to the future directions. I get excited about a lot of work. I would welcome opportunities to collaborate, and I've had great conversations with many of you over the last couple of days about ways in which we could do that. I went to a really neat workshop at the University of Wyoming this past fall, all about conservation and protection of wildlife corridors for migration corridors for wildlife. And so that I'm really interested in continuing that kind of work because I think it really links into a lot of the work I do on agri-environmental policies, since a lot of agricultural lands, croplands, pasture lands, ranch lands are impacted by, or we should think about that management because they affect these migration corridors. I'm excited about that. Would love to do more work thinking specifically about the adoption of the best management practices, including specifically ones that impact water table management. So this can be really seen as a tool to help mitigate risks, particularly under different climate scenarios when you might face shocks of too much water or not enough water. So I'm interested in thinking more about that, how it can make farms more resilient. And so I'm excited about continuing work in that direction. I mentioned at the beginning, I really want to do some of the work that I was doing more of 4 years ago, in which I'm coupling the experimental data with models that look at how things change really across that landscape. So I would welcome collaborations with interdisciplinary teams that could help do that. So I'm really excited. I think if we want to really talk about real scenarios, policies on the ground, then we can learn about behavior and we can link that to understand, okay, well then what would that mean, right? So if we know how behavior would change, we can run different scenarios and then look at outcomes we care about, whether it be water quality, whether it be something related to wildlife, etc. And on that same kind of idea, I think this provides a lot of opportunity, again, to think about those climate shocks. So in the context of climate change, how does it affect crop choice, management practices, productivity, and ultimately also these environmental outcomes, since it's all connected. And I see the coupled models as being the way to really think carefully about these kinds of issues. And I see the experiments as a way to really think carefully about behavior, which then informs the models. So I think they're very connected, and I think we talked about this yesterday in the faculty meeting. I love the kind of work I do, but sometimes I worry, oh, I've gotten really narrow here. Let's broaden out, think about the systems approach, bring in the right people in order to fully think about these problems. So I'm very excited about that. So I hope that I've given you a good overview of who I am, the type of work I do and would like to do, and I would be happy to have a discussion about anything that I just said, and I really appreciate you all being here. Thank you. Yes.
Anybody have a question? But I wanted to jump my first question. So, in your experiment, the switch between the ambient tax and your subsidy assurance situation, it has this flavor of loss aversion to it.
Yeah.
And I was wondering if you had thought to test for loss aversion across T2, T3. You're obviously not ready to kind of test group, but there may have been some difference between if very loss-averse people are going to act very differently in T2 than they would T3, I would think.
So Jordan and I actually had a conversation about this, and it's a really good point, because there's the loss aversion, there's also a loss framing thing that also impacts, both relate but are actually kind of a little different in our minds. So we don't feel like we designed the experiment to really be able to tell whether either of those issues are necessarily affecting behavior. We kind of were like thinking through it, and we said, oh, well, if we think that the framing, the loss framing impacted behavior, then you would expect people, actually, you would expect in T3, which is the subsidy reduction, that people would have actually reduced pollution and tried to be even more careful than in T2, which is the ambient tax. That was kind of what we were thinking in that discussion. If you have a different perspective on that, we just didn't find that. And so we were like, well, we're not really picking up any differences there, and we didn't feel like we were able to measure that specifically. I don't know, if you have other thoughts, I'd be happy to hear. Yeah. No, we didn't see that.
And there's the same issue with this touched on loss aversion that preferences. Those are
Oh. Maybe.
yeah.
If you were to experiment again, set up to where you put in some kind of trust game with these type of options, because producers together they communicate and signal to each other, obviously with your sign. And if you were to say, okay, let's do a trust game, but with these type of scenarios together, do you think you'd actually end up with a different answer than, because mapping trust and risk has obviously been an issue, and it's hard to say, is trust a risky decision? So you do in a game with these scenarios and have them cooperate together or signal to each other, you would actually arrive at a different equilibrium.
I think that's a great question. I think we would have seen a lot more people choosing the most cost-effective abatement strategy, which was to reduce pollution through input choice, and not going to that costly action, because they could have potentially been more confident in the whole group's decision to use that strategy reliably and to meet that water quality threshold. So I think that's likely what would have happened if we had allowed that communication. That's what I would expect. So in that paper I mentioned in Resource and Energy Economics that just came out, in which we allowed for multiple types of heterogeneity, we did test communication, and that did provide, so heterogeneity in general made it harder to reach the Nash, but then the communication helped, and providing information even without communication also helped. So providing information about what the best choices for you and people like you and what others did that are like you helped. So I think you're spot on with what would likely occur. Yeah. Yes.
So I grew up in Illinois, and CRP was a big deal for many, many years. Is that being directed more now to environmental? As I recall, it was production based at one point. Is any of that correct? And can you comment on that?
Yeah, so the great question, the Conservation Reserve Program, yeah, they really are focusing on a whole suite of environmental outcomes and using that environmental benefits index in order to rank land parcels and thinking about whether they want to enroll them into that program. Yes, so you're exactly right there. The reason I don't talk much about the Conservation Reserve Program, at least in this presentation, is because that's, as you pointed out, a land retirement program in which you're taking land out of production and putting it into some kind of natural grasses, natural state. And my focus for a lot of my work is on the working lands programs, but I'm glad you brought it up. It's certainly a very critical program that we use in the U.S. So, yeah. Yes.
So my question is about the treatments and whether or not they co-occurred and when participants actually discovered the decisions of the other group members.
Oh, yeah. Okay.
So could they see the decision-making process, for example, and then the game ended and then that was it? Or was it only after everyone had decided and entered their decision?
Round of decisions, outcomes. Round of decisions, outcomes. Okay. But they couldn't see what you specifically did, right? Okay. It was ambient pollution, outcomes. So they did get to see that outcome, but they just knew in aggregate what happened in their group. They didn't know, what did you do? What did you do? So, yes.
So because I wonder if in a real scenario where you have farmers, and obviously farmers know each other, right? And they may talk about what their decision is regarding sort of this subsidy assurance, right? And if I was maybe a smart farmer knowing that I'm actually going to pay more than I'm going to get in the benefit if I just adopt the technology, I might wait for everyone else to adopt.
Yeah.
And then just reduce my inputs to make sure I'm not over the average threshold and pay the tax.
So yeah, you're thinking more of a dynamic setting, what they might do as more people jump on, and then they decide they're going to free ride.
Right.
Yeah. So that could happen. I guess one of the things we're emphasizing with communication and signaling in the real landscape is that we're hoping that it doesn't encourage free riding, but it more creates a new social norm where people want to be part of this either program or just movement, and they're proud of what they're doing because farmers care about their land. So that's kind of what we're hoping. is what the outcome would be.
Well, and not and just to clarify too, because a farmer could, my understanding is, do different changes, right, and reduce their pollution. So they're still acting as a good steward, but they're not paying sort of that inefficiency cost of having certainty.
Yeah, and let me say two things about that. First, I want to be really clear about how that was a parameterization decision in this experiment, and it might look differently in other cases. So, but excellent point. But also, what I'm really hopeful for, I mean, what we can do with precision ag is just unbelievable. The amount of data that exists about agriculture, decisions that are made on the farm, input choices, yields, etc. So things that have typically been considered to be unobservable in the past, like input decisions, they are more and more observable. Well, if we get the data, they're more and more observable. A lot of that's very private. So maybe someone could just demonstrate their commitment using the monitors that are in a lot of these really sophisticated agricultural systems. And so maybe that provides a way to acknowledge behavior that in the past has been very difficult to acknowledge. Yeah, great point.
Hey, I just had a question about one of the findings. In one of the scenarios, and I can't remember which one, you said that it was cheaper for the participants to reduce inputs. Which one was that? I can't remember.
It was always cheaper.
Always cheaper. Now, does that imply that the firm was just deciding not to produce? Like, were yields also going down, or was there it just was not worth it to maximize production on your property because of the avoiding of the subsidy loss, I think it was?
Yes, good point, good point. So it did not necessarily connect directly to yields, but it did connect to profits. So, and those profits, so if you recall how I set it up, the only extra cost I considered was the cost of adopting that conservation technology. But within that kind of production income function, so I shouldn't have said profit, I should have said production income function, that is both the benefits and costs, so benefits being like yields and costs of production of that input choice and that production. So it's not necessarily true that reducing input, so if we think about fertilizer, that marginal changes in input levels would really impact yields that much. It's not necessarily true because of how the yield response curve to like fertilizer inputs. But the point you're making with the experiment is it would have, it's the production income versus the cost of this technology. So production income would have either been high and then they adopt this conservation technology and that dropped it a little, or they lower the production income a little bit but then don't absorb this other cost. So there's like two levers.
I think
and they're
I
both
get it. So on
cost-
aggregate, they might actually
Yeah, you
make
have to
more
think
money,
about them together.
but it's because they're not producing as much. Is that
They haven't used as much inputs, yeah.
Okay.
We don't map directly to like what that would look like in terms of yield.
okay?
But
Thank
it
you.
would be the income from production. Yeah, there's certain things that we just allow to happen within the function, and we don't really care like, well, what did yield look like and what did production costs look like and we don't think about that one as much. But it's just all absorbed in the same function. Yeah. Yes.
Yeah, back to the previous point. So I know in the research on common pool results, they can have the self-enforcing organization within the group, saying that you have 6 students, and 3 of them are great. We can become association, and basically we open book to each other. And as a result, everybody knows other people's action. And the people usually use this research to focus on the portion behavior for the outsiders. That's something you can think about. But as a person who works on macro theory, in other words, I'm not on the ground. So I just question about one thing. So just in the theoretical point, in your last treatment, at the end of the day, everybody kind of want to install the technology and do whatever. And to my point of view, it's not quite interesting. An interesting result should be somebody already did that, and the followers will not. And in other words, you have an asymmetric Nash and see who is the beginner to use the technology. And maybe that's something, yeah, you can think in the future.
So what you're saying is what you would find more interesting is whether people, the
If you-
NASH differed between people.
Yeah, if you use the technology, then maybe I should not.
Yeah.
That will be something more interesting to think about.
Maybe I should have presented this REE paper. So
Yeah.
they do in the REE, because of the heterogeneity, that's driving the different NASH equilibrium for those individuals. So some of them, so we parameterized it, so half of the people, their best choice was to adopt the conservation technology, and for the other half, it was not. So that does introduce that richness there. So I mean, it certainly makes things much more complex.
Yeah.
So I find this interesting though, but go for it.
And a really short question.
Yeah.
Why you have within subject instead of between subject design?
Yeah, we did that just, to be quite honest, because of the constraints we had about our budget and time. So
I
we
see.
wanted to have people in and just do all of them. Between subjects is cleaner.
Thank you. So I had a question about the nature of the free riding that shows up in the game. So do you tend to see people all sneak a little bit, or do you tend to see sort of serial and full polluters in the game? Because I appreciate that they don't know why the ambient pollution's gone up in this game, but I can imagine if I were sitting there saying, do I want to pay for a costly piece of security? Ultimately, my choice might depend on whether I think I've got a stinker next door or whether I think everybody's sneaking a little bit, because the stinker next door is never going to change their behavior.
Yeah. So I take your point. I do want to make a clarification. So the choice to adopt or not adopt the conservation technology, if you didn't adopt, it didn't necessarily mean at all that you were free riding. So we had a lot of people that didn't adopt, but then they reduced their pollution through that input lever, right? Because there were two levers to reduce pollution. So we have not looked, I have not done a close analysis of people that just persistently polluted and didn't respond. There weren't many of them because in general we were hitting pretty close to those water quality targets. So we actually didn't see a lot of that free riding behavior. You're right though, it would be interesting to go and look at those. In this experiment, they wouldn't have had a lot of information about what specific other individuals were doing, but certainly we could look at those previous penalties, that variable that I mentioned, because that speaks to their experience with people that aren't contributing. So I could go back and look at those, look at that impact a little bit. I do think it's somewhat captured though in that variable, because if you experienced a lot of penalties in the past, you try to protect yourself and say, yo, I want to be careful here. Yeah.
Think about cow jail. So Eleanor Ostrom's cow jails, right? So it might be interesting. You have a flag for virtue signaling. It might be interesting to also do a flag for those people who are polluters, right? So, I mean, it's hard to put land in jail, right? But this is the cow jail, right? And so just as a thought for maybe something fun to do in the future, and it would seem like it'd be fairly easy to flip it around, right? So neighbors can actually signal that one of their fellow, neighbors is a bad actor, and they put a sign on their property saying, I'm a polluter or whatever. So just an idea.
Interesting.
Any other final questions?
So I was very intrigued by your initial findings from the surveys of actual farmers and the tenants. I'm not really surprised by that. It seems kind of like it's actually pretty. It makes more sense the more professional you are, right? That you're going to be able to take advantage of these policies, right? And so the more people you rent from isn't really a burden, right? Because you know how to fill out the paperwork, you know how to contact and be in there. So my question is, what are the other activities that are going on for these farmers that are associated with these decisions? So I'm thinking about my home state of South Dakota, where pheasant hunting is a huge, both economic and cultural part of the rural landscape. So how are other non-economic, but maybe economic reasons going to be associated with the uptake in this conservation?
I love that question. So I had this really interesting conversation recently at this, it was a workshop in the Chesapeake Bay, so I'm on the Scientific and Technical Advisory Committee, and it was a workshop about targeting. As economists, we think a lot about like how can we target our dollars to certain areas of landscape. Well, that's not the important part. The important part was we had this really cool conversation about ducks unlimited and trout unlimited, right? And the person talking, there's not just economists in this meeting, there are all different kinds of folks, and I don't remember this gentleman's background, but he said, you all need to be better. You need to be like ducks unlimited and trout unlimited, because you go and talk to a landowner or producer and you say, hey, I like hunting. You like hunting? Look what we can do if we preserve this wetland, and it's a win-win. You get to hunt, you get to shoot those ducks, and the same with the water quality conversation, and that it was a way to connect with people that, yeah, maybe you're not even close to the water. You know, Mississippi River Basin's huge. A lot of people aren't thinking about the Gulf on a daily basis, right? So maybe you're not connected to the final output, but you can link into a local issue. So I think that's part of what you're getting at. Like, what are the local factors that are happening that are more immediate to that operation and would impact decisions? And I think linking into the other values that these individuals have and how, you know, their land operates and what services are provided is really critical. And I just don't feel like we've done enough work in that area. But does that sort of get at your, I mean, I think we need to go in and talk about, I mean, people have different opinions on the value of talking about co-benefits. I think that there's a lot of value in talking about co-benefits, because water quality benefits, we can get wildlife habitat benefits, we can get creation benefits from the hunting that comes from doing that, and maybe we don't talk about some of the benefits and we just focus on the others because the others come with it. I think it's a really interesting thing to think about.
So let's let Leah off the hook. Give her a little bit of a chance to take a breather here. We'd like to get your feedback on the presentation today. There's a form outside that you can do that. We appreciate you stopping by on the way out to fill out the form. But with that, help me join Leah. Thanking Leah for coming today.
Around there, it's Norris Lake.
Thanks for the water.